My name's Steve Rowe. I work for LucidWorks, and I'm the Lucene PMC chair. I'm going to give a brief intro for myself, give some highlights of the recent Leucine Solar 4.0 release, make a pitch for all of you to contribute to Leucine Solar, and tell you some of the things we've been doing to make that easier for you, and then describe some of the work that was done by Google Summer of Code students, and then some of the things we're working on for the next release, 4.1, and the next releases after that. So I'm a committer on Leucine Solar and the PMC chair. I'm also a JFlex committer. JFlex is a scanner generator software that is used for some of the analysis components in Lucene. For example, standard tokenizer and HTML strip char filter. Last month I joined LucidWorks, and previously I worked for the Center for Natural Language Processing at Syracuse University. That's my Twitter handle, low volume, I promise. So this is excerpted from the Lucene 4.0 release notes. It looks kind of long, but it's a huge release. This is probably, well, certainly the most revolutionary release that Lucene has ever had. So it's a long list, but that's for a reason. Firstly, flexible indexing, which is sometimes referred to as pluggable codecs, which are suites of index formats. Flexible scoring, which provides more index statistics and similarities that use them. For example, BM25 language modeling, divergence from randomness, and information-based models. Document writers per thread, the DWPT there, is faster multi-threaded indexing as a result of concurrent flushing. So if you have the hardware to throw at it, Lucene can index much faster. Doc values, which are typed single-valued fields and can be used for flexible sorting and scoring. And I say flexible because they can either be RAM resident or read from disk, and don't need to be parsed because they're stored in pre-parsed form. Norms, which are used to encode things like document field boosts as well as length norm factors for scoring, are now stored as doc values. And as a result, you get everything that you get from doc values, which means that norms aren't limited to just a single byte as they have been. Several of the data structures are used. For example, the terms dictionary and index, as well as the field cache, use RAM more efficiently now. Terms are stored in the index as byte arrays instead of strings. And as a result, it's possible now, although there aren't any implementations of it, to store different encodings in the index. Filtering is faster. Merge I/O can be rate limited to reduce I/O contention so that querying, you can adjust the extent to which querying is impacted by concurrent indexing. Fuzzy search is now 100 to 200 times faster. Index reader is now per segment, and Uwe Schindler, he's here I think, is going to be giving a talk about that next, yes. Spatial search has been completely reworked, and of course many bug fixes and optimizations. And there are links down there if you take a look at the slides later for changes in migrate.txt files that contain lots more details. Again, this is a lossily compressed version of the release notes, so I apologize if the lossiness is too much. But anyway, Other speakers are going to be talking about Solar 4 and Solar Cloud, so I'm just going to quickly go over these. Solar Cloud provides distributed indexing, NRT and NoSQL features, for example, real-time get, optimistic logging, and durable updates. High availability with no single point of failure, automatic forwarding and redundancy of updates sent to any node, automatic load balance distributed search with failover for queries sent to any node. Real-time get is access to the latest version of a document without having to first perform commits or open new searchers. Optimistic locking and versioning, when used with real-time get, ensures that there are no conflicting concurrent changes. Durable updates means that uncommitted documents are never lost. And atomic updates are a form of incremental field modifications, adds, updates, I don't have it here, but deletes as well as increments, are implemented via storing all the fields for the document. And then when a request for a modification comes in, the document is combined with the request parameters to be fully re-indexed. And last but not least, a brand new web admin UI with Solar Cloud support and improved error reporting. There's several features I didn't mention, and of course, a huge amount of bug fixes and optimizations. And again, the link to the detailed changes is down there. LucidWorks produces an Apache Solar reference guide, and that should be coming out next week for Solar 4. This is a list of statistics that I collected about the Lucene and Solar 4.0 releases. I looked at commits over the branches that contributed to 4.0 releases and collected the numbers. And there's nearly 8,000 commits that went into just the 4.0 versions of Lucene and Solar. And you see I don't break these down by project because roughly between version 3 and 3.1, the development teams merged for Lucene and Solar. So although it may be possible to split out commits that were exclusively for one project or another, the two of them are intertwined enough that would be a lot of work. So I've only included those stats for the combined projects. Similarly, for the feature branches, there are 18 separate feature branches, which I use a little loosely here to mean throwaway branches, scratch branches, as well as heavier duty feature branches on which stuff that couldn't be committed right away was developed. The next line about excuse me, contributors. The larger number includes committers, and you can see that about, let's see, twice as many non-committer contributors contributed to Lucene 4.0. I took these stats from the change list, which gives credit to people who have contributed to various developments in Lucene and Solar. Similarly for Solar, there are actually something like 3 times as many non-committers who contributed to the Solar 4.0. The next stat, the lines of code, I collected by running a project named CLOC, which is hosted at SourceForge, over the 4.0 tag on Subversion. And I've included, because it's just a single stat, both code and comment lines, because I think comments are sometimes at least as important as the code. So it's quite a large chunk of code there for each of the 2 projects. The next set of numbers, I won't go over individually, but these are JIRA issues that were resolved as fixed. Down at the bottom there, you can see 2,500 separate issues that were fixed just as part of Lucene and Solar 4.0. So next, the pitch for all of you to join, if you aren't already in Lucene and Solar development. So I give links here to wiki pages that are maintained that describe the processes by which people can contribute, how to get the code, what the conventions are for code layout, that sort of thing. The project has been working consciously toward reducing barriers to inclusion of other people's work, and I want to describe some of those efforts. So one of the things we're doing is doing better at modularizing the code so that there are fewer couplings between the various components. I mentioned flexible indexing and scoring. Both of those, while they provided an opportunity to create implementations that are useful in their own right, were intended to make it much simpler both for committers as well as other contributors to innovate and play around with features without having to understand the entire code base. Another thing we're doing is we run tests in continuous integration servers, Jenkins, that look for problems in Java docs, problems in code patterns that we don't like. I think system out, right? Uwe, isn't that one example? Another thing we're trying to do is release more frequently, and this is something that we've struggled with for years, essentially. These two graphs here represent the release intervals between the major releases that Lucene has seen. So approximately 5.5 years interval between Lucene 1 and Lucene 2, which is unbelievably long. Between 2 and 3, something like 3.5 years, and then between 3 and 4, 3 years. Similarly, the release interval, or the average release interval between minor releases in the 1.x release cycle was something like 1.5 years. For the 3.x release cycle, it's down to about 5 months on average between minor releases, which still seems unacceptably high, but at least we're moving in the right direction. One of the things we're trying to do to lower the bar to actually performing a release is put together automatic machinery that is building releases on a regular basis and tests them via the continuous integration server and emails the development list when there's something that's going wrong. Maybe the benefits are self-evident, but I wrote them down anyway here. One of the issues we struggle with in the project is backwards compatibility. So generally we've made guarantees about index compatibility. That is that a major version can always read previous major versions' indexes, and about API compatibility. The longer the release cycles are, that means the longer we have to live with these sometimes outdated APIs and index formats. So that'll help us if we can reduce that. Also, we think people are more motivated to contribute if they think their work will be released soon. Some of the other things we're doing are improving testing. David Weiss, one of the committers on Lucene, has contributed a couple of libraries that help us to perform randomized testing, where rather than having static tests that always test the same paths over and over, randomly injects various forms of randomness. So different components that adhere to the same contract are switched out so that we are always testing different paths. It's not all that useful if you don't have a way to repeat the path that caused a problem, and that's one of the things that this library provides. If you want to run those tests, if you want to know how to run those tests, there's a convenient target there called ant test help that you can run from any module's directory, and it'll tell you some of the knobs you can twist to get testing to work for you. For example, you could test just a single method in a class, and of course ant test alone will run all the tests from the point in the source tree that you are downward. We're also running multiple installations of Jenkins. One of them by Simon Wilnauer, the Flunkings.com, one by Uwe Schindler, the SD Data Solutions, and finally one that's hosted by the ASF. And those run multiple platforms, and Uwe Schindler's instance also randomly selects different JVM vendors and versions and 32 and 64-bit versions in order to get a wider variety of environments that will help us find bugs. We also try to make it simpler for people to approach the code, and one of the ways we can do that is we provide pre-built projects, configurations for these two IDEs, for IntelliJ IDEA and Eclipse. So if at the top level you say ant IDEA, that will populate a project for you. You just go to that directory and open it up, and bingo, IntelliJ works for you. Similarly for Eclipse. We also have Maven POMs that are used to perform Maven releases, which can actually drive the build. And I give a short synopsis there of how to do that. If you want more information about using Maven with Leucine Solar, you can read that DevTools Maven readme.maven file I've listed there. Finally, one of the things we're doing to encourage people to always be thinking about making, or about the possibility of making revolutionary changes is that we always have two development branches going in parallel. Trunk can host changes that are just too radical to work within the stable release, and the stable branch, at this point, branch 4.x, off of which 4.0 was released. Trunk in the future will become branch 5.x, or branch 5.x rather. Previous branches, so for example, the 3.x release line is bug fix only. So it may be that there will be a 3.6.2 release at some point. But we don't do further development once we've produced another release and switched on Trunk for the next version. So every change gets committed to Trunk and then backported to the stable release branch. And we hope that this model will allow for orderly API and index backward compatibility transitions. As I mentioned in the stats for 4.0, we regularly use temporary branches to collaborate on complex changes that we don't fully understand how they'll impact the stable and trunk branches. Next, I want to talk about the two Google Summer of Code projects that Lucene hosted. This is the second year, I think, that Lucene has hosted students. The two students that we hosted this year were Han Zhang and Nikola Tankovic. Han Zhang's project was to add a block postings format to replace Lucene's variable end postings. And Simon Wilnauer said in his talk that people don't like issue lengths, but I've got tons of them in here, so mea culpa. Sorry about that. And Nikola Tankovic's project is breaking out stored field from indexable field. Among other things, people have struggled sometimes with understanding the difference between a document they get back from a search and a document they provide to indexing. And hopefully, I don't think that this transition will be fully complete until 5.x, but hopefully those two concepts will be split apart enough that won't cause people trouble any longer. So block postings format was actually available in 4.0, but is not the default. It'll become the default posting format for 4.1 and has been renamed to Lucene 4.1 postings format. The benefits are the index size is reduced, and query throughput is increased, and that payloads and offsets are stored in separate streams, so you don't pay for them unless you use them. Some technical details here about what's going on. There's a fixed block size of, by default, 128 integers, and fixed bit width packed ints are put into these blocks, and the number of bits per integer is the maximum bits per integer, rather the bits required to encode the maximum integer in the block. I didn't have that written down correctly there. So if there are fewer than 128 integers, they're encoded as a vint block, a variable integer block, and blocks contain all the same type. So frequencies are not mixed with the other forms of data that are stored in the index, for example, but the blocks of the same type are interleaved, although vint blocks here it says aren't. So lots more detail about this are at the link below at Mike McCandless's blog about this. The other Google Summer of Code project about splitting indexable field and stored field. I mentioned a little bit before about one of the motivations for making this change, that sometimes there's confusion. People want to re-index a document they've retrieved from a search, but that's not kosher. So making that harder for people to make that mistake is one of the motivations here. I think because of API backward compatibility, I'm not entirely sure, that change won't be complete until Lucene 5.0. So next I'm going to talk about Lucene 4.1, and I looked at the number of issues that are open for 4.1. It's something like 500 of them right at this point. So there's no way I'm going to cover anything anywhere near that many of them. I'll be talking about a few of them. There's a lot of work going on suggesters right now. Two of them are analyzing suggester and fuzzy suggester. For analyzing suggester, you supply pairs of strings and weights and an analyzer, and a weighted FST indexes the analyzed forms, and lookups analyze queries and suggests the unanalyzed form. So for example, if you wanted to perform term normalization, someone types in AME, they could be suggested amélie, where there's some casing changes and diacritics that were stripped by the person typing it in, I guess. Also synonyms could be served here by allowing matches against things that, so if someone were to start typing in the word wireless, as I have here in this example, Wi-Fi router could be suggested. Fuzzy suggester is a form, or extends analyzing suggester to also provide up to 2 Levenstein edits. So this could be used to provide spelling correction over normalization and synonyms. So here there's a transposition of the L and the E, which could still, as a result of, that was only, I think transpositions is just a single edit. So that would allow for suggesting amélie again. And again, there's a blog post here by Mike McCandless that you can look at if you want more details about those. Another thing coming in 4.1 is compressing stored fields format. This is work done by Adrien Grand. Is he here today? There he is. I hope I didn't mangle your name too badly, Adrien. This is a replacement for the stored fields format in Lucene, which doesn't perform any compression at all in 4.0, and from versions 3.0 through 4.0, there wasn't any compression for stored fields available. The idea is that I/O cache hit rate can be improved by compressing stored fields, and also by keeping the index into the compressed fields in memory. There's a choice of 3 separate compression algorithms, LZ4, which is the default, and is very fast at both compression and decompression. LZ4 HC, which I think stands for high compression, which just takes more memory and time when performing compression, but is decompressed by the same decompressor as LZ4 algorithm. And Java Util Deflator, which does a better job at compression, but is slower. I think I already mentioned that LZ4 has low overhead in general, but also for incompressible input, it has very low overhead. The compression is performed into a fixed minimum chunk size, by default 16K. Larger blocks improve compression ratio, but uses more index time memory. One of the key benefits of this algorithm is that documents don't span chunks, so you never have to perform more than a single seek in order to load a document. There is a limitation, though, that the maximum per document combined fields lengths are 2 gigabytes less your chunk size. So I'm reporting a benchmark that Adrien performed that he lists on his blog post, which I give a link to down there at the bottom, where he indexed 10 million 1K docs from Wikipedia, from Mike McCandless's Lucene utils, and I found that indexing speed was comparable. Stored fields on disk were stored at a ratio of about 0.61. An average document load time was twice as fast, or better than twice as fast. Adrien also tells me that Robert Muir found that he got something like 0.35, I think, compression ratio over geonames.org. This is using the default LZ4 compression algorithm. It's looking like this will be the default stored fields format for Lucene 4.1. So without doing anything, when you upgrade to 4.1, suddenly your index will be smaller, thanks to Adrien. I think that issue hasn't been committed yet. Is that right, Adrien? Right. So Lucene, beyond Lucene 4.1. I hope, Simon, that I don't misrepresent here the work you've been doing. Simon Wilnauer has been working for over a year and a half on a project to make positional queries faster. So the current system for positional queries in Lucene is called span queries, and there has been a cry afoot for lo these years to nuke spans, and position iterators is the way to go, we're hoping. So this is a work in progress. Simon Wilnauer and a couple of collaborators at this point have been working on Lucene 2878 in order to bring this capability to Lucene. I give a link here to a paper that Simon consulted when he was implementing algorithms they describe for efficient, optimally lazy, minimal interval semantics. So unpacking that a little bit, minimal interval semantics just means that when you're finding intervals or spans, that is terms that are related positionally, those which are closest to each other, that is take up the minimum interval, are the most relevant generally to the piece of information you're looking for. Efficient is obvious. Optimally lazy algorithms, when these algorithms run, there are some speedups that can be performed by not checking every single interval when they're run. And I don't know all the details. If you have questions about this, you can ask Simon. I'm sure he can help. These algorithms have been implemented in MG4J for several years. As I said, this is used to implement efficient proximity filtering and scoring. At this point, scoring isn't implemented, but I think Alan Woodward is working on that problem, actually. Filtering is implemented. One of the benefits of this approach is that it decouples the positional operations from scoring and matching, so that you can augment any query with these positional operations. So the span query hierarchy requires every single query to be implemented in terms of span queries. So this is a really heavyweight solution. Hopefully, the position intervals work will allow these two operations to occur in parallel. Another one of the benefits that can be gotten from position iterators is faster, more relevant highlighting. The two approaches for highlighting that are in Lucene right now are reanalysis and term vectors. And neither should be required once this stuff comes online. And highlighting is already implemented. Isn't that right, using these position intervals? In the API for the position iterators, it's possible to request subintervals to be collected. It's less work not to do so, which is why it's an option. So, for example, highlighting needs to collect all the information about where the intervals have occurred in order to do its work properly. But other forms of positional queries don't necessarily need to do that, which is an optimization. The high performance use case is to use these not over all of the hits for a particular query, but rather to run two passes. First, run queries normally and then rescore the top n of, Simon says, 1 to 100 using positions. As I said earlier, this is a work in progress, so I'm not saying 4.1. 4.2 may be a little optimistic, actually, but it's coming. So at this point, positional scoring isn't complete. There's no payload support, and multi-phrase query isn't supported either. So this table attempts, hopefully better rather than worse, to make a comparison between the existing span queries and the position iterators and queries or scorers that use them. In the middle there, I have the authors of the paper describing these algorithms, the name for the operator that's being implemented by these queries. So span or query uses the disjunction interval iterator and is used by disjunction max and disjunction sum scorers. I don't think that there are any span queries corresponding to, or at least I couldn't find any, for conjunction and phrasal operators, the block operator. But conjunction interval iterator and conjunction scorer are used with the AND operator, and the block operator for phrasal is, not unexpectedly, block interval iterator and phrase query. Span near query comes with an option to match either in order or out of order, and these correspond to these two separate Boldian-Vigna operators and the ordered and unordered near queries that are implemented as part of the position iterator's work. The span not query, which Boldian-Vigna call the Brauerian difference operator, I'm sure I'm not getting that pronunciation correct, is implemented as the non-overlapping query. So this is the case where, for example, you want to match a conjunction of two words that occur in the same sentence, for example. You could index pseudo terms in between sentences, and then use this non-overlapping query to make sure that your positional query doesn't span multiple sentences. It's one use for that. Span first query isn't implemented by the position arrays at this point, but Simon assures me that it would be trivial to do so, as there is already this range interval iterator that allows you to specify absolute positions. So there's a huge energy right now around suggester improvements, and I list here actually what's a subset of the issues that have been opened like within the last month or so to make improvements over suggesters. 4491 supports outputs separately from the suggest key and allows custom suggesters to extend results, including metadata, and it represents a refactoring of the suggester API. This is another one of Simon Wilnauer's issues. 4492 makes suggesters immutable, and I think as part, or 4491 and 92 are part of the same work. I think the idea is that once a suggester has been built, it isn't going to be modified, and as a result, there are some optimizations that can be performed to make it work better. 4517 allows for user-supplied suggestion filtering. So if, for example, you wanted to filter for a particular category over some large set of things, so you didn't want to have a separate suggester for different types of products, for example, this issue would allow for people to supply an arbitrary function which would look at the thing being suggested and then yay or nay whether it should be suggested. 4518 allows for analyzing suggesters to return user-typed input, for example, for highlighting. 4450, I think the people working on 4517 and 4450 should talk to each other, because this is another form of a filtering, in this case, a particular kind of function over, I think this one is to restrict to a particular distance. Finally, I think there's only one issue here. Oh, there's two, sorry. Two issues that likely aren't going to make it into the 4.x releases. First of these is an issue that's been around almost as long as Lucene, and certainly as long as Solar. The idea that people want to be able to do incremental field updates, that is, rather than re-indexing documents when there's a change to just some part of it, they want to be able to make modifications to individual fields. So I list here some of the workarounds and implementations is kind, I guess. Some of the ways that people are trying to deal with this now. You can keep the original documents and then update the document. In this case, I believe they just get fully reanalyzed. There is a facility called Parallel Reader that has been renamed in 4.0 as a result of the atomic reader issues to Parallel Composite and Parallel Atomic Readers, which keeps sort of slices of an index. All of a set of fields for all documents are in one reader, and or rather in one index, and all of a separate set of fields are in another. An application has to provide a way to keep the document IDs, the internal document IDs, in sync. So this isn't so much a solution as it is if you, perhaps this would work for you if you had static indexes, but that sort of defeats the whole point. So this is not a route people generally go down. Solar has a facility called External File Field, probably a lot of you are aware of. This is accessible via function query only, but allows for an external file to be read in after a commit to be consulted for the value of a field. So if your use case is such that you have small enough values that can be updated at commit intervals, then you can make use of this to provide the single incremental fields. You can store everything and reanalyze. So this is one of the Solar 4 features that's, I don't know if you are familiar with the issue numbers in Solar, but this is a 3-digit issue number, which means that it's almost as old as Solar itself, and just recently made it into Solar. But this is the idea where you store every field for a document, and when you provide a request to perform some modification on a field, it combines that request with all of the store fields, reanalyzes, and then indexes the document again. Finally, field values as an external DB key. It seems like an obvious solution if you have a way to quickly make updates to a DB if you only maintain a key in your Lucene index. So I list here really 3 proposals and 1 proof of concept for how to implement incremental field updates in Lucene. The first 2 of them are referred to as stacked segments. Andrzej Białecki's issue does this by performing a mapping between document IDs in one segment and another segment which is stacked over it. And then upon query, a merging of these 2 segments, mapping from the original document ID to the stacked segment ID. This is definitely a work in progress. Similarly, Shai Herrera's and Sivan Yogev's stacked segments proposal, I think there's a patch on that issue, but it's obviously not fully working. I say deletishly here. I don't fully understand the mechanism. These first ones are things that people have tried and people do in order to work around the lack of this feature in Lucene and until recently Solar. I'm being told I need to stop though because I'm running out of time. I have one more slide about term vectors. I took over this slot from Robert Buer, and he had on his agenda covering things that could be done with term vectors, which are essentially single document mini-inverted indexes. He's recently added payloads to term vectors, and he thinks, as a result, because it's possible to make a single document index reader around the vector, this could be used to enhance highlighting. So for example, multi-term queries don't have to be written against the entire terms dictionary, and highlighting that performs queries that use payloads to do scoring would work out much better against such a scheme. And file format improvements are possible now that term vectors have codec support, for example, compression or possibly optimization for query expansion, for example, feedback. In summary, Solar and Lucene need you, and I've got some handy Apache shortened URLs here for you to find those wiki pages, and a list of open issues for 4.1. This is the 500 I was talking about. Run our tests. If you want a feature or you found a bug, let us know. And if you're a student, please seek us out for Google Summer of Code next year. And I don't think we have time for questions, but thank you very much.